things that I was most interested in college were logic, and I was fascinated by how the brain could create new knowledge, what seemed like new knowledge, in associating and in creativity. And those same characteristics of what I was interested in human thought, in thinking, are the very elements of thinking that's disturbed in people with schizophrenia. One of the very difficult things about schizophrenia and about having the illness is that all the medicines that we have to treat the illness, we have just discovered accidentally. We have not understood the tissue mechanisms of the illness. We don't understand how the brain makes a hallucination. We don't understand how the brain develops paranoid thoughts. If we knew exactly what the brain mechanisms were for doing that, then we would know what kind of drugs to develop that specifically address those mechanisms. I take a look at the brain of a schizophrenic at work using some of the modern brain imaging methods that we have today. I developed a model for how the brain could generate hallucinations, how the brain could generate paranoia. What I'm hoping to do is to develop a very concrete mechanism for the elements that generate psychotic thinking, and then that would be the basis for new treatments that we could develop in the future. The most important people in this are Steve and Connie Lieber. They've been really leaders in the goals of NARSAD for such a long time that it makes me very proud to be the Lieber Prize awardee.
My mother was diagnosed with schizophrenia when I was a little boy and lost custody of us, so I was raised by my dad. The stigma was such that no one ever even told me my mother was mentally ill. Things have changed enormously since then. We study postmortem human brains, and in particular we've been very interested in the genes that increase risk for major mental illness, especially schizophrenia. We've been particularly interested in studying how genes change across normal human brain development so that we would understand how the genetic variation that's going to increase risk for schizophrenia would work. We're determined to map the genetics of all the major mental illnesses. What we've found in almost every gene we've looked at in detail so far, the genetic variability that's increasing risk for disease is beginning to do this while the fetus is being developed, while the brain is being developed. And we created a map. We could see how these genes were changing across the human lifespan. We were beginning to understand how the brain was developing. We need to understand how you think and feel at a molecular level so we can develop new treatments to improve those things when the person is sick. We're determined to map the genetics and the messenger RNAs of all the major mental illnesses and normal human brains over the next few years. The Brain and Behavior Research Foundation, in providing grants for researchers, has provided hope not just for the researchers that are trying to make advances, but for the patients, the beneficiaries of that research.
I was an impressionable 19, 20-year-old when I had some of my formative experiences working in hospitals. I had not seen such incredible pain before, and people whose lives were wasting away from mental illnesses we knew very little about. And as a young person, I found myself very moved by it. What we're hoping to do in our clinic and in our research is to eventually develop a roadmap for a treatment protocol for adolescents and kids with bipolar disorder. For many years, we've been testing a treatment called family-focused therapy. The idea is that the combination of family intervention and medication is going to work better than medication alone. Our current most significant effort right now is to try to see if we can prevent the onset of bipolar disorder in kids who are genetically at risk. So what we're interested in now is intervening early with family intervention, family-focused therapy, to try to determine if we can stave off the onset of the disorder or at least make it less severe when it does occur. What I'm trying to offer families are a set of skills for coping with the disorder. And what I'm trying to offer the patient is an understanding of what he or she has and how it impacts the family. I'm very grateful to be getting this award. I think what it will allow us to do is go a step further with our research on high-risk kids. It may allow us to measure certain outcomes that we wouldn't measure otherwise in certain family processes. It will enrich, enliven the research that we're doing.
I'm Carlos Zarate. I work at the Intramural Research Program at the National Institute of Mental Health. I'm an adult psychiatrist specializing in psychopharmacology, and I research severe mental illnesses, particularly bipolar disorder and treatment-resistant depression. We do research in severe mental illness, and bottom line, we're trying to find better treatments for our patients. So one of the exciting things that we're working on is a drug called ketamine. Ketamine is a drug that goes to a receptor in the brain called NMDA. It's part of the glutamate receptor. And we have shown that in several studies that if you directly target this receptor in the brain called NMDA with ketamine, you can produce a rapid antidepressant effects within hours. We have broken the sound barrier, where it is clear now that we can develop treatments that work very rapidly within hours, as opposed to having to accept for years and several decades. We have to wait weeks and months. For me, it's an exciting time to be a researcher. We didn't have much of these technologies even a decade ago, and now we have all these options and possibilities. And that will definitely, and it has led to an increased understanding what are the causes of the illness, maybe what are potentially promising targets to develop better treatments. These things we didn't have in recent past. I strongly believe that we need funding and support for mental illness, and I'm extremely pleased that this foundation has recognized bipolar disorder as worthy of study.
Researchers really live for being able to spend their time, spend their lives devoted to alleviating suffering from others and using our skills at answering questions. What gives me the most excitement is getting the answers to my questions and knowing that those answers might someday make the life for a child even a little bit easier. I'm trying to understand the causes of emotional problems in children, and my interest focuses most deeply on how anxiety disorders place kids at risk for other kinds of problems like depression. The particular aspect of brain function that my group studies is how emotion is represented in the brain of children. And we're interested in both negative emotions, particularly fear and anxiety, but also positive emotions. If we can understand better how to recognize mental health problems in kids, not only might we be able to impact how kids are doing, but we're also going to be able to have a significant impact on adults. BBRF, by directly funding young investigators, has really made it possible for a lot of scientists to get their start who then have gone on to make major contributions. BBRF has this unique ability to create a buzz, a sense of excitement, and most importantly, a sense of hope. As we understand the way in which the brain goes awry, we can be very hopeful that we're going to discover new ways to treat brain diseases and to understand them.
What excites a scientist is the fact that he's looking at something that no one else in the world has ever looked at. And when a scientist discovers something wonderful, he says, that's beautiful. The way an artist would say, that's beautiful. I run a laboratory that's interested in understanding the physiological basis of cognitive problems. I look at a very small series of questions to understand how a small chunk of neural processing predicts or is associated with behavior. By studying monkeys, we can look at the actual neural processing that goes on. By understanding the processing of those networks, we can begin to understand what goes awry in those diseases and what are the biochemical, the neurotransmitter effects that enable the drugs that we have to work and that might enable us to design better drugs or even better therapy. What BBRF does is funds ideas. Everybody who works in systems neuroscience and tries to understand how the brain works is intensely grateful to an organization that supports that research. To understand the brain the way we understand the galaxy, the way we understand the atom. And that's what science is to ask the question why, I wonder why, and find the answer.
Quite early in my clinical training as a psychiatrist, I came to a realization that we have very limited understanding of the mechanisms of psychiatric illness and also have very limited choices of treatment for our patients. And we're not even close to the level of cure for severe mental illness. And that made me think about moving into an area of work where I could make a difference. My area of research is psychosis, and specifically the biological markers of psychosis. What we're trying to do in our work is to look at the psychosis as a dimension that cuts across diagnostic categories. And mainly we are interested in schizophrenia and psychotic bipolar disorder, with the overall goal to identify these biological markers that could underlie the mechanisms of psychosis. And the implication is clear that psychosis might be a separate diagnosis which have separate risk factors and might also require separate treatments in the future. Receiving the Sidney Bear Award is a very high honor and makes it all meaningful. This award will help us to continue our research in the biological markers of psychosis and continue us to do what we do and hopefully come with some solid biological markers as well as some novel targets for intervention in the future.
Research has been my life. There's never a dull moment, and I really think we have such a tremendous responsibility, but we also have such a tremendous opportunity to make a difference to people who are suffering from these disorders. I think there's been a real paradigm shift in the last 5 to 10 years in how schizophrenia and psychiatric disorders are really perceived. It's been really interesting to see how these have moved away from being phenomenological disorders to now actually being viewed as disorders of the development and function of the brain. My laboratory's main focus is to try and understand the cellular and molecular basis of genetic risk susceptibility for psychiatric disorders, with a particular emphasis on schizophrenia. What we've been trying to do is use a varying breadth of tools to try to get a clearer understanding at the biological level of how these genes work. Looking at the expression of genes or proteins in the brain of individuals with patients with schizophrenia and across the lifespan of normal developing humans. This has given us some insight into the illness. I think that we're actually trying to understand how genes translate at the level of brain and behaviour. So if we think about how genes influence cancer or how genes influence heart disease, it's a very similar approach. Well, it's a tremendous honour to be the recipient of the 2011 Bear Prize, it really is. The prize itself will facilitate our research greatly. It will contribute to advancing technologies that we're currently working on to try to target therapeutic targets in these biological pathways to further treatments of schizophrenia.